Hey guys, welcome to this video. So in this YouTube short, I want to discuss the beauty of statistical mechanics. So it's the crack of dawn, and I was just thinking about this yesterday night. I pulled an all-nighter. I was just going through my to-do list because my final semester examinations of my undergraduate degree just ended. And although I am mostly, I have been preoccupied with quantum mechanics for most of the initial years of my undergraduate degree, and in fact, my love of physics initially came from that was probably my first love within physics, quantum mechanics. And even today, most of my friends and classmates will probably associate me with quantum mechanics more than statistical mechanics. But in the final semester, I learned statistical mechanics, and also it's a very, what I found the most beautiful about stat mech was that we start with very symmetric arguments. Symmetric arguments means very logical arguments that are based entirely on logic, no physics, nothing. Like, you don't assume any laws of physics, it's just logic. For instance, the postulate of equal a priori probability. That might sound technical, and I cannot explain explain that in a YouTube short, but yeah, it's entirely logical. Then you have ergodic hypothesis and these kind of things. So anyway, you start with very logical hypothesis in statistical mechanics. What happens when a lot of particles, and as the name suggests, it's statistics, it's logic, law of large numbers, averaging effect and all. But from there, if you build up using some basic physics, you can explain a lot of the asymmetry in the world around us. For instance, why is the Maxwell-Boltzmann distribution the way it is and not something else? Why is the mean energy of an ideal gas 3 by 2 RT and not something else? All these kind of things, you can actually get the results that you learned from high schools. PV equals nRT, the state of that equation of state of an ideal gas. All of this you can derive, but that's the beauty of StatMech. And plus, you see, although StatMech deals with all this in equilibrium systems, what we call equilibrium systems, because you can only apply all this logic, like for entropy, you're defining Boltzmann entropy, then you're taking the delta ln z equals 0, where z is the partition function. All this is technical, but yeah, we do this only for equilibrium systems. But everything around us is not in equilibrium. If everything around us was in equilibrium, then of course there would be no change, nothing. We wouldn't exist in the first place. And we are moving towards that state, of course. But yeah, right now everything around us is not in equilibrium, and that's why there is something called non-equilibrium StatMech, more the study of complex systems, non-linear dynamics, more complicated thing. But StatMech is the basic starting point, the basic philosophy, and I think it's very important to learn the approach of StatMech if you want to do physics, whatever it is. And yeah, that's what I wanted to share in this video. I find StatMech very beautiful and kind of a bit different from the other usual branches of physics like classical mechanics and quantum mechanics. And yeah, that's what I wanted to share in this video.